The Amazon, a living ocean of green, stretching beyond the horizon and breathing clouds into the sky. But millions of years ago, this wasn't a forest at all. It was a sea. Roughly 20 million years ago, the heart of South America lay submerged beneath a colossal inland lake known as Lake Pebas, a watery empire larger than modern Spain. It stretched from Peru to Venezuela, teeming with crocodiles as long as buses, turtles the size of cars, and dolphins that hunted by sound in the darkness. Scientists estimate that this prehistoric lake covered more than 1.1 million square kilometers, forming when the rising Andes Mountains trapped rivers in the continent's interior. It was a place of extremes, heat, pressure, and predators, where life evolved at a furious pace. Today, the Amazon's rivers still trace the outlines of that lost inland sea. Each flood, each surge of muddy water is a whisper from a world that came before. So how did a mountain chain create an ocean? And how did its disappearance give birth to the greatest rainforest on Earth? Before we dive in, make sure you subscribe to Beyond Extinction, where we uncover the worlds that vanished to shape the one we know. Because the story of the Amazon's birth doesn't begin in a forest. It begins underwater. The story starts in the Miocene epoch, around 21 million years ago, when South America was still an isolated continent. To the west, the Nazca Plate slid beneath the South American plate, driving the slow, relentless rise of the Andes Mountains. That uplift changed everything. Rivers that once drained west into the Pacific became trapped between the growing mountains and the ancient Brazilian Shield to the east. With nowhere to flow, they pooled into vast floodplains that merged over time into an enormous, shallow lake, the Pebas system. Sediment cores from Peru's Iquitos Basin show deposits more than 2 kilometers thick, recording millions of years of steady flooding. According to Karina Horn et al., Science 2010, this basin became a continental-scale wetland, a vast shifting mosaic of deltas, lagoons, and swamp forests. Fossil pollen from these sediments reveals a tropical landscape, palms, giant lilies, and ferns thriving in constant humidity. Paleogeographic reconstructions by Vesseling et al., 2002, show that at its greatest extent, Pebas may have covered territory spanning Peru, Brazil, Colombia, and Venezuela. In places, it reached depths of 40 to 50 meters. To early geologists, it seemed impossible that such a lake could exist so far inland, until fossils began to tell the story. Shells of marine snails and clams were discovered thousands of kilometers from any modern coastline. Skeletons of dolphins, crocodiles, and freshwater manatees lay buried deep in tropical clay. Each fragment pointed to the same revelation. Where rainforest now thrives, an ancient sea once ruled. And within that inland sea, under the heat of a changing world, evolution worked at full throttle. The Pebas system became a crucible, forging monsters, shaping survivors, and laying the foundations of the Amazon's future. Long before the Amazon River carved its path to the Atlantic, South America's fate was sealed beneath the slow rise of mountains. Along the continent's western edge, the Nazca Plate sank beneath the South American plate, forcing layers of rock skyward to form the Andes. The process was almost invisible in a human lifetime, just fractions of a millimeter each year. But over millions of years, it reshaped an entire world. As the Andes rose higher, they began to act like a dam. Rivers that once drained west into the Pacific were blocked, trapped between the rising mountains and the ancient Brazilian Shield to the east. The result was a vast inland depression, a bowl where rainwater, runoff, and sediments gathered for centuries. Scientists studying geological cores from the Iquitos Basin in Peru have found over 2 kilometers of accumulated sediment, evidence of repeated flooding over more than 10 million years. Within those layers lie the fossils of mollusks, pollen, and aquatic plants, all pointing to a sprawling freshwater world that once stretched across the northern half of South America. According to Jaramillo et al., published in PNAS in 2010, The uplift of the Andes didn't just trap water, it changed the climate. The new mountain barrier redirected rainfall, creating a zone of constant storms that poured into the growing basin. The lake expanded until it covered about 1.1 million square kilometers, its shallow waters forming a network of lagoons and swamps rather than a single body. In some areas, Pebas was no deeper than a few meters. In others, it plunged to 50 meters. A scale so immense that it rivaled inland seas like the Paratethys in Eurasia. And through all that change, life adapted. Fish evolved to breathe in stagnant water. Trees grew amphibious roots. Even the soil began to transform into the rich, silty foundation that still nourishes the Amazon today. But Pebas wasn't a stable paradise. As the Andes continued to rise, tectonic shifts caused earthquakes, floods, and sudden changes in water level. The region became a living experiment, its ecosystems constantly redrawn by geology. And in this unstable, heat-soaked world, evolution began to move faster, favoring size, strength, and survival above all else. Because the Miocene wasn't just an age of water, it was an age of heat. The air thickened, the seas warmed, and life itself began to scale upward. What followed was a transformation unlike anything the planet had seen since the time of the dinosaurs. If you stood at the edge of Pebas during the Middle Miocene, the air would have felt like a furnace. The heat clung to your skin, the humidity soaked through your clothes, and every sound, insects, thunder, the hiss of water, echoed in the heavy stillness. Global temperatures were 3 to 4 degrees Celsius higher than today, and atmospheric carbon dioxide hovered between 500 and 600 parts per million, according to Pagani et al., published in Nature in 2009. The world's ice caps shrank, sea levels rose, and tropical climates expanded deep into continental interiors. Pebas was one of the great beneficiaries of this warming, a hothouse world of endless water and light. Fossil pollen and plant remains reveal a landscape dominated by palms, ferns, and giant water lilies, some spanning 2 meters across. Thick mats of algae covered the surface, feeding clouds of invertebrates and fish below. The lake was shallow in most places, oxygen poor, and heavy with nutrients. Perfect for creatures that thrived in murky, still waters. Scientists describe Pebas as a mega-wetland mosaic, a labyrinth of lakes, rivers, and marshes that changed shape with every flood and drought. During dry seasons, isolated pools baked in the sun. When rains returned, they merged into a single inland sea. This constant cycle of expansion and retreat forced animals to adapt rapidly, driving bursts of evolution that shaped the ancestors of many Amazonian species today. But warmth has always been both gift and curse. The same climate that encouraged lush vegetation also fueled storms and chaotic rainfall. Organic matter decayed quickly, releasing methane and carbon into the air. The Pebas system was a greenhouse within a greenhouse, a self-sustaining loop of life, decay, and rebirth. And within that heat, evolution crowned its giants. Crocodiles, freed from the limits of smaller rivers, grew into behemoths. Their diversity exploded into 14 species, each built for a different purpose, some for speed, others for brute force. And one of them would rise above them all, becoming not just the ruler of Pebas, but the most powerful crocodilian the world has ever known. In the Pebas wetlands, power didn't belong to mammals or birds. It belonged to reptiles. Fossil evidence from Peru, Colombia, and Venezuela reveals that these waters hosted at least 14 species of crocodilians, more than any ecosystem today. Each had its own way to survive in the Miocene heat. Some were hunters, others scavengers, and a few grew into giants that defied imagination. At the top of this reptilian hierarchy stood Purosaurus brasiliensis, the undisputed titan of the Miocene. The first fragments of its skull were discovered in 1892 in Brazil's Acre Basin, and later finds confirmed what those early bones had hinted: This creature was monstrous. Scientists estimate it reached 9 to 12.5 meters long and weighed around 6 tons, though some reconstructions suggest maximum lengths of 15 meters and weights approaching 12 tons. Heavier than an orca. Its skull alone measured 1.5 meters, reinforced like armor. According to biomechanical modeling by Erickson et al., in 2012, Purosaurus could deliver a bite force of up to 69,000 newtons, nearly twice that of Tyrannosaurus rex. Each tooth was 5 centimeters long, conical, and sharpened by evolution to pierce bone without snapping. This was a predator that didn't chase. It waited. One lunge from below, and the fight was over before it began. Fossilized shells of the giant turtle Stupendimes bear bite marks that match Purosaurus' teeth perfectly, some even showing signs of healing, proof that a few lucky victims survived the encounter. Its massive body was covered in thick osteoderms, and its muscular tail could propel it through the water like a torpedo. It was, by every measure, the apex predator of Pebas. But it wasn't alone. The long-snouted Gryposuchus croizati, stretching over 10 meters, hunted fish in the shallows, using its slender jaws to slice through schools like living scissors. And the bizarre Morasuchus adipus, sometimes called the duck crocodile, had a flat, wide skull nearly a meter long, which scientists believe it used to filter feed small prey from muddy water. As explained by Salas Gismondi et al., in Nature Communications, 2015, this diversity came from niche partitioning, predators dividing the ecosystem by behavior and habitat to avoid direct competition. In Pebas, one species didn't dominate. Many coexisted by mastering different hunting strategies. Still, balance didn't mean peace. When the dry season shrank the lakes, the giants clashed. Skull fossils show puncture marks and fractures, evidence of battles over territory and mates. It was a brutal world, but a thriving one. For millions of years, crocodilians reigned supreme, shaping the ecosystem with every ambush, every ripple, every kill. And while most life fled from them, a few creatures developed an opposite strategy. They stayed, endured, and turned their vulnerability into their greatest strength. They became walking fortresses, armored and unyielding, proof that survival didn't always belong to the fastest or fiercest. While crocodiles ruled through fear, another lineage ruled through fortitude. Deep in the Pebas wetlands swam Stupendimes geographicus, the largest freshwater turtle ever known, a reptile so massive that even Purosaurus thought twice before attacking. First described in the 1970s and re-examined in 2020 by Cadena and Sanchez Villagra, fossils of Stupendimes have been unearthed across Venezuela and Colombia. Its shell stretched up to 2.86 meters long and weighed over 1 ton, larger than a small car. Some individuals had horn-like extensions at the front of their shells, possibly used in combat between males or as extra defense. Yet even these giants bore scars. Several Stupendimes fossils display deep gouges shaped exactly like Purosaurus teeth. In one remarkable case, a broken crocodile tooth was found still embedded in the shell, the predator's failed strike immortalized in bone. Somehow, the turtle survived, its shell healing around the wound. But Stupendimes was not alone in these ancient waters. A second turtle, the recently described Caninimes tridentata, 2023, was unlike anything seen before. It had a broad, flat skull armed with 3 sharp ridges, a trident-like beak built for shearing flesh or cracking shells. CT scans reveal powerful jaw muscles, suggesting a crushing bite strong enough to splinter mollusks and even smaller reptiles. Where Stupendimes relied on defense, Caninimes embodied offense. Both show how evolution in Pebas rewarded size and specialization. Armor for some, weaponry for others. As predators grew stronger, prey grew tougher. It was an endless biological arms race waged across the murky waters. Still, even the most formidable armor couldn't protect against time. Environmental pressures were mounting. The wetlands were heating, the water growing shallower and oxygen levels dropping. Gigantism, once an advantage, was becoming a burden. Yet, while reptiles fought and evolved in the swamp's depths, a new kind of creature was arriving. Warm-blooded, intelligent, and unexpectedly adaptable. Against all odds, mammals began to carve out their place in this reptilian world. For millions of years, the Pebas wetlands were a reptilian empire. Yet even here, under the rule of crocodiles and armored giants, a few warm-blooded pioneers found a way to thrive. Their strategy wasn't brute strength, it was adaptability. Among them were the river dolphins, ancestors of today's pink Amazonian boto. But the Miocene versions were far more formidable. In Peru's Iquitos Formation, paleontologists uncovered the skull of Pebanista yacaruna, the largest freshwater dolphin ever discovered. Based on cranial reconstructions by Bianucci et al., 2018, adults reached between 3.3 and 3.6 meters long, roughly one-third larger than any living river dolphin. Unlike its modern relatives, Pebanista wasn't a gentle fish eater. Its teeth were thick and conical, its jaws elongated but strong, and its skull reinforced to withstand the thrashing of large prey. Scientists believe it hunted in near darkness using echolocation, a sonar-like system that let it see through Pebas's mud-choked waters. CT scans show early adaptations of the same fatty organ, or melon, that modern dolphins use to focus sound. Alongside the dolphins swam the sirenians, ancient manatee relatives with barrel-shaped bodies and heavy bones for ballast. Fossils from Colombia and northern Brazil suggest they reached lengths of around 3 meters, feeding on seagrasses and aquatic plants. They were slow, peaceful grazers, drifting through lagoons as shadowy predators lurked below. These mammals were newcomers in a world they did not dominate. They hugged the lake's edges, where the waters were shallow and vegetation offered cover. And yet, their presence reveals how adaptable life could be, even in an environment seemingly built for reptiles. Around them, other mammals began to appear. Fossilized jaws of early monkeys, bats, and rodents show that Pebas's islands and shorelines were already nurturing the ancestors of today's Amazonian fauna. Each of these species was a small rebellion against the reptilian order, a whisper of the future that would one day replace it. Because while Pebas was still ruled by scaled titans, another kind of terror was rising on land. Predators with legs and claws that could run, chase, and kill in broad daylight. If the waters of Pebas were ruled by crocodiles, the land belonged to their cousins, and to creatures that looked like nightmares given feathers. The world beyond the lake's edge was an arena of speed, precision, and violence. The Cebitids were the land-dwelling cousins of crocodiles, reptiles that had traded sluggish swimming for explosive sprinting. Fossils from Venezuela's Urumaco Formation reveal predators with deep, narrow skulls, serrated teeth, and upright legs built for pursuit. The largest, Barinasuchus arvaloi, stretched between 7.5 and 10 meters long and weighed around 2 tons. Unlike modern crocs, it could run on land at speeds up to 40 kilometers per hour. According to Sanchez et al., 2013, its skull and jaw were designed not for crushing, but slicing, more like a predatory dinosaur than any living reptile. Sharing this violent landscape were the Forus racids, better known as terror birds. These flightless predators stood over 2.5 meters tall, towering above most mammals. Their curved beaks could deliver downward strikes with devastating force, and their long legs made them swift hunters on the open floodplains. Studies of their neck vertebrae show immense muscle attachments, suggesting they killed with precision, using powerful stabbing motions rather than grappling. Imagine standing on a Miocene riverbank, the air heavy with heat, the mud alive with motion. To your left, a 2-ton land crocodile bursts from cover. To your right, a giant bird charges, wings outstretched, beak gleaming like a blade. Between them, herds of sloths and rodents flee for their lives, churning the shallows as water erupts in splashes of foam and teeth. Even these killers weren't invincible. Fossil bones of terror birds bear circular puncture marks that match crocodilian jaws, proof that some met their end in ambushes at the water's edge. The tracks of cebecids and birds, preserved side by side in ancient mudstone, tell of encounters between rival predators, neither willing to yield. On land and in water alike, Pebas was a theater of evolution at full volume. Reptiles and birds still held the crown, but their reign was nearing its end. The mountains to the west continued to rise, slowly tipping the continent eastward. Rivers began to find a way out, and with each passing millennium, the great inland sea began to shrink. The predators, the giants, the entire flooded world of Pebas was about to give way, not to extinction, but to transformation. For all its monsters, Pebas was also a sanctuary of gentle giants, herbivores that fed the ecosystem, recycled its nutrients, and shaped its landscapes. They were the living engines of this drowned world, as vital as the predators that hunted them. The most improbable among them was the Phoberomys pattersoni, the largest rodent that ever lived. Imagine a capybara scaled up to nearly 3 meters long and weighing over 700 kilograms. Fossils unearthed in Venezuela's Urumaco Formation by Roncon et al. 2004 show sturdy legs and webbed feet, perfect for wading and swimming. Its giant front teeth and grinding molars reveal a grazer's diet, tough marsh grasses and reeds. Like a hippo-sized guinea pig, Phoberomys likely spent its days in water, feeding in herds, and relying on numbers rather than speed for protection. Nearby lumbered the ground sloths, far removed from their slow, tree-dwelling descendants. 10 genera of them are known from Pebas deposits, ranging from sheep-sized browsers to the 4-ton Urumacotherium, larger than an elephant. Isotopic analysis from Antoine et al. 2016 shows they fed on aquatic plants and low vegetation, often wallowing in the shallows to stay cool. With long claws and immense bulk, these sloths were slow but nearly unassailable. The strangest of Pebas's grazers were the Astropotheres, giant tusked mammals resembling a cross between a tapir and a hippo. Some species grew up to 3 meters long and weighed over a ton. Their long snouts and muscular lips allowed them to uproot aquatic vegetation, maintaining open channels through thick marshland. Fossils of their footprints and dung show they moved in groups, reshaping wetlands, much like modern elephants reshape savannas. Together, these massive herbivores transformed the landscape. Their movement churned the mud, creating new feeding grounds for fish. Their droppings fertilized the water, sustaining the plankton blooms that fed the entire ecosystem. Scientists estimate the Pebas Basin's biomass density rivaled that of today's Pantanal, one of the richest wetlands on Earth. Standing on a Miocene riverbank, you'd see a living mosaic. Herds of Phoberomys wallowing in reeds, Astropotheres grunting through flooded plains, and sloths dragging tails through the mud like slow-moving ships. And in the still water behind them, a ripple, a shadow. The same eternal reminder that in Pebas, paradise and peril were never far apart. But this extraordinary world was reaching its final chapter. The same forces that had created Lake Pebas, tectonic uplift, rising rainfall, and trapped water, were about to undo it all. The sea was about to drain, and from its death, a new world would begin. Pebas didn't end in a cataclysm. It ended in silence, one slow tilt at a time. As the Andes Mountains continued to rise, they shifted the balance of the continent, forcing water to seek new paths. The inland sea began to leak eastward, drop by drop, until the greatest transformation in South American history was underway. Sediment records show that around 10 to 7 million years ago, the calm, fine clays of Pebas gave way to coarser river sands. Fossil mollusks adapted to still water disappeared, replaced by species suited to flowing streams. According to Horn et al., Science 2010, this marks the exact moment when the great inland lake evolved into the world's largest river system, the Proto-Amazon. The change was devastating for Pebas' giants. The vast, quiet waters that had sustained them drained into narrow rivers. Purosaurus and Morisuchus lost their hunting grounds. Stupendomes and Phoberomes vanished from the fossil record. Whole food webs collapsed. Yet, from the survivors came new life. Genetic research by Hubert and Reno, 2006, shows that nearly 30% of modern Amazonian fish species descend from Pebas lineages that adapted to faster, shallower currents. As the lake drained, forests invaded its fertile mudflats. Trees took root in the nutrient-rich soils left by millions of years of sedimentation. Over time, these forests grew denser, more complex, until the basin transformed from swamp to jungle. What had once been the bottom of a lake became the foundation of the Amazon rainforest. And the river that replaced Pebas was unlike anything Earth had ever seen. The newborn Amazon River stretched across the continent, eventually spanning 6,900 kilometers and carrying 20% of all freshwater reaching the world's oceans. Even today, when it floods, it reenacts the memory of its birth. Vast tracts of forest disappearing underwater, just as they did 10 million years ago. In the story of the planet, few deaths have ever been so creative. Pebas vanished, but in its place rose the largest, richest ecosystem on Earth. Today, when we look at the Amazon from above, it feels endless, a boundless green ocean of life. But buried beneath its roots lies the ghost of the true ocean that came before it. Lake Pebas may be gone, but its fingerprints remain everywhere. Marine shells are still found in Andean rock faces more than 1,000 kilometers from the nearest coast, silent witnesses of when the mountains were seabeds. Deep within the Amazon's floodplains, sediment cores still hold the microscopic fossils of Pebas' algae and plankton. Even the genes of modern fish trace back to those ancient waters, carrying a story written in DNA long before the first human set foot here. As Antoine et al., 2016, and Horn et al., 2010, note, the collapse of Lake Pebas didn't just alter geography. It created the foundation for South America's modern biodiversity. Its sediments became the soils that now nourish the rainforest. Its extinction set the stage for the explosion of life that defines the Amazon today. Every year, when the rivers rise and flood the forest, the land remembers. Dolphins glide between trees. Fish weave through the roots. And for a few months, the jungle becomes a sea again. The rhythm of Pebas still beats beneath the surface, a pulse that never stopped. The Amazon, for all its grandeur, is a resurrection, a forest reborn from the bones of a vanished world. The rain that falls here, the rivers that run, the creatures that call it home, all are living echoes of that ancient inland sea. If this journey through Earth's forgotten oceans stirred your imagination, tap like, share it with a fellow explorer, and subscribe to Beyond Extinction, where we resurrect the worlds that time forgot. Because every forest, every mountain, every drop of rain carries the memory of something that came before. Pebas may have vanished, but its story still flows, in the rivers of the Amazon, and in the pulse of the planet itself.